Hi, everyone. Thank you for standing by. As a reminder, this event is being recorded and will be archived on pumpsandsystems.com. I'm Amy Hyde, Editor-in-Chief of Pumps and Systems Media. Welcome to When to Use an AODD Pump, Applications, Design, and Considerations, sponsored by Unibloc Hygienic Technologies. Our presenter today is Caleb Summers. Caleb is an experienced multidisciplinary mechanical engineer who enjoys diving deeply into how a system works to improve its operation. At this time, it is our pleasure to begin the webinar. Stay tuned after the presentation for the Q&A session. Please send your questions through the Ask Question box, and we'll get to as many of them as possible. Now I'll turn it over to Caleb to begin the presentation.
Welcome to our webinar on AODDs. My name is Caleb Summers. I'm currently a lead application engineer at Unibloc Hygienic Technologies, and I've been working here for 5 years. And then prior to that, I've been working with different mechanical systems in different fields for well over a decade. At Unibloc, we offer a broad line of pumps predominantly focused on the food, pharmaceutical, and sanitary transport industries. But we've touched a little bit of everything. While I've dealt with multiple types of pumps on the day-to-day, for this webinar, we're going to focus solely on air-operated double-diaphragm pumps, which I'll probably just say AODDs or diaphragm pumps from here on out. First thing will just be a quick refresher on a diaphragm pump. Then we'll discuss their benefits and where they excel over different styles. And then we'll even discuss some of their downfalls and reasons why you would not want to go with an AODD. And then lastly, we're going to talk about some of the innovations and lesser known aspects of diaphragm pumps. And I'll try and sprinkle as many real world examples throughout. AODDs were originally designed in the 1950s for the industrial market. And so they're heavily present or prevalent in the industrial market. But as their features and benefits became more known, they started to be adopted by the sanitary industry as well. And so as consumers started using those for broader applications, the manufacturers also innovated and updated diaphragm pumps to keep up with these new markets. And before we go too much more in depth on the pumps, we'll do the brief refresher on how they work. As the name Air-Operated Double-Diaphragm Pump implies, they are powered by compressed air, and they have two diaphragms that move back and forth to move the product. So starting at the bottom of this diagram is the inlet manifold, and the majority of the time the inlet is going to be on the bottom because the majority of diaphragm pumps use ball valves, and ball valves need gravity to work. I even had a customer who wanted to mount his pump sideways above a 55-gallon drum so he could keep it as close to the drum as possible. And then he called me upset because it was just spraying water everywhere and not working like it should. And so I had to tell him, no, you have to make sure your pump is oriented in the right direction. You can't mount them whatever way you want. So you go from the inlet to your inlet check valves, which we said are typically the ball valves. And then above that, you get to the product chambers and the air chambers. And these are separated by those diaphragms. And so the way it works is it will pressurize one air chamber, which will push product up through the outlet check valves. And then on the opposite side, that diaphragm is getting pulled in, which pulls product up through the inlet check valves. And then as it oscillates back and forth, it's continually pulling product into one side and pushing it out on the other. And then at the very top is your outlet manifold, which you connect to your process pipework. So that was all the conventional style AODD. There are some alternative styles as well. And so the operation is exactly the same. It's two diaphragms, and there's an air side that is pressurizing one side than the other. The main difference is that the product goes through the center of the pump and the air is on the outside. And then visually, it obviously looks a lot different, and we'll get a little bit more into some of those benefits later in the presentation. But yeah, visually, it is a very different pump, but operating principles are all exactly the same. One thing to note is it doesn't have necessarily an inlet manifold. It just has an inlet where the product goes straight into the pump. And so that is beneficial in reducing your suction length. So with so many options for pump types, the big question is, how do you know when an AODD is the best option? And so that's my job, is to make sure you leave this webinar knowing that answer. Some of the main things to look for is your product shear sensitive? Do you need a pump that can do suction lift? Is there any chance for running dry or deadheading the pump? What's the viscosity of your product? Does it have any solids in it? And what's the environment like? Is it going to be a hazardous location? And then just kind of general application overview. So is it going to be just straight transfer, or are you doing a filling, more precise application? First two topics is run dry and deadhead. So running dry can be an issue because most pumps have a rotating shaft. So your low gear, twin screw, there's a rotating shaft, and you have to seal that. And so you've got a rotating seal component and a stationary seal component that are constant out of friction, which creates. And so on your typical seal design, the product that you're pumping is both the coolant and the lubricant for that seal. So if you're running dry and you don't have any product going through that pump, that seal is going to heat up very quickly, and generally for extended run dry periods, it will fail. AODDs don't have any rotating components at all. So there is no shaft seal. It's just a check ball with some O-rings, and then your process connections, generally like a tri-clamp gasket or an O-ring, or just even a thread that seals. So there's not really many leak paths. And so that's why an AODD is great for a run dry application. You're not worried about burning up any seals. A peristaltic pump is a pump that kind of gets away with having a rotating component and being able to run dry. And this is because all of the product is contained in a hose, so there's no seal around their rotating shafts. Next would be the ability to deadhead. Once again, low gear and twin screw pumps, they're great at generating pressure, which is good for pumping thick products long distances. But if your discharge line gets blocked or a valve gets closed, they're going to keep generating pressure and heat, and then it will keep spinning until something gives, whether it's the valve or the pump itself. AODDs are pretty unique in the fact that when they're run against a closed valve, the pressure in the line will increase up to the point where it's equal to the air pressure powering the pump, and then it just stops. So where deadheading on most of your pumps is an accident and can quickly lead to failure, on an AODD, deadheading can be used as a method of operation. I've had several customers before who will transferring product from, a mixer to a hopper on a filler or something like that. They just have a valve at the hopper, and when it's full, they'll close it, and then the pump will stop pumping. And then when they need a little bit more in the hopper, they just open the valve, and the line pressure drops, whereas that air pressure is the same. And so since the air pressure is higher, the pump just kicks back on and starts pumping again. And so if there's ever a chance for deadheading, an AODD is a great option. And then one of the biggest, if not the biggest, draw of a diaphragm pump is its ability to self-prime and suction lift product. They are generally capable of about 12 feet of dry suction and almost 30 feet of wet. And this is extremely useful, especially in the food industry, because that's what I'm most used to, but I assume in the industrial industry as well. So many products are sold in 55-gallon drums. And with that standardized format for selling products, an AODD is a great pump to get the product out of those drums. And on top of it, working with like thinner products like waters or oils, AODDs can handle highly viscous products as well. And one thing to note, kind of like a little tip on pulling suction, is that there are more limitations on how much a pump can suction lift than how much it can pump. So it's best to make sure when you're sizing a pump that's going to be doing some suction is to size it for the suction more so than the discharge. And so you won't always need a bigger pump to get the flow rate you want. Sometimes you just need a larger inlet connection because that makes the suction lift easier. So that's a good tip. Products, and then keeping that suction distance as short as possible, since that's the harder thing for the pump. A kind of non-pumping example, something that it made me think of is back in college, I worked on a farm and we would do square bales of hay. And so the baler would go through and it would leave, a square bale every 10 feet. And then we'd have a big trailer we were supposed to put them on. So instead of driving the trailer to the field, grabbing a bale, walking to the trailer, walking back to another one, we drove the trailer through the field. So you walk next to it, you pick up a bale, you throw it on the trailer, and the trailer does all the hard work. And so that's kind of how suction lift works with an AODD. You don't want to be doing all the work walking when a truck and trailer is going to do all the heavy lifting for you. You don't want the suction to be moving your product the majority of your distance. You want to be pushing it the majority of your distance. It's going to work a lot better. So talking about hard work, because moving square bales is very hard work in the summer, AODDs are great at moving those thick products or those difficult products that some other pumps like a centrifugal pump might struggle with. And that includes products that have solids suspended in them. So the thickest product we've pumped with one of our diaphragm pumps is we had an OEM in Belgium that specialized in medical grade silicones for scar prevention and treatment. And so they needed a safe, clean way to move this 500,000 centipoise silicone elastomer from their 55-gallon drums to a mixing vessel. And so we were able to offer them a barrel unloading system that was able to handle the viscosity and their CIP and sanitary requirements. And then another just really common thick product that we deal with is tomato products. So whether it's going to be diced tomatoes where you don't want to damage the chunks, or triple thick tomato concentrate, the AODD is a great option for that. And then for some of those higher ends, you're going to want to pair that diaphragm pump with an unloading system that allows you to get to those higher viscosities. So AODDs have large clearances that enable them to pump those solids, but on top of the large clearances between the moving components, the check balls, they also have a large product chamber and any lack of any rotating assembly inside the pump. And these features help reduce the amount of shear that the pump imparts on the fluid. This is really important for shear-sensitive products like chocolate. If you don't pump chocolate correctly, it can seize up, which if you're a manufacturer, that's ruining your product. And so an example of why an AODD is a good, we had a customer who was pumping chocolate. They had multiple different kinds of chocolate they were doing, some of which had almonds or fruit solids in them. And so the AODD was the best option for not seizing the product up, handling the solids. And we have an easy teardown feature with the specific AODD pump we sold that allowed them to quickly and easily clean the pump in between the different products to make sure they didn't get any cross-contamination between batches. Another thing that is where the low shear comes into play is with prepared foods. So we've had people who pump like lentil curries where you don't want to damage the small lentils that are already cooked. And so product preservation is a great reason to pick an AODD pump. And not only does it protect the product and handle those viscosities, it handles a wide range of viscosities. And so that's where the AODD can really set itself apart. Low pumps and twin screw pumps can also handle viscosities fairly well, and depending on how they're spec'd, can handle some solids. But you're generally selecting a gear reducer and motor size for that specific viscosity, whatever the customer's pumping. It's hard to spec a lobe or a twin screw pump that'll handle something that's, as thin as water and as thick as tomato paste. You're generally going to have the power and speed for one of those, but not both. that's not an issue for AODDs. They will easily pump something as thin as water or something as thick as tomato paste with the same pump, and there's no need to change anything about it to make it fit those applications. An example of this is we had a global personal care manufacturer that needed to pump their full range of hygienic products to fill depositors. And since this was a contract manufacturer, they never knew what product they were going to get. And so the main requirement they had for us was the ability to pump the full range of their products, their thinnest to their thickest, if it had some solids in it or not. They wanted a pump that would do it all, and it needed to be cleaned in place. So they chose an AODD because you don't have to have a different gear motor or reducer for those different applications. And then with the alternative style AODDs, it's easier to make them CI peelable. And so they didn't have to do any manual intervention when switching between the products. Run a CIP cycle, and then the pump was ready to go for the next product. Some tips for pumping thick products would be when you're looking at pumps or trying to decide which pump might be best, the curve's going to be based off of water. So if you're pumping something thicker, that pump's not going to be able to match the performance on the curve since that curve is water. And kind of a easy example of this is water is 8 pounds per gallon, whereas honey is 12 pounds per gallon. So you might be able to lift, 12 feet of water, but that's not nearly as much weight as lifting honey 12 feet with that extra weight to it. And then on top of that, viscosity isn't always going to be directly related to a product's density. So just because the product's thicker doesn't necessarily mean it's heavier. So knowing your product is really important, not just its viscosity, but its density and other properties as well. And then for suction lift of a viscous product, if you're pulling from a drum or a tote, you're going to need to lift at least 4 feet. Totes are generally right at that 4-foot mark, and the drums are a little bit shorter. And then when something is getting pulled out with a wand or a hose, or it's too thick for a wand or a hose to go down into the drum, a drum unloader is extremely helpful. So on that 500,000 centipoise application, we quoted an unloader. And so that's where you put the pump on a plate, and that plate is put in the drum, and the pump is lowered into the drum on top of that plate. And so what this does is it makes the effective distance that you're lifting the product is only the distance between the bottom of that plate to that first check ball. And so for a conventional AODD, it's going to be, 4 inches or so because they've got that inlet manifold. And for the alternative style AODDs, it could be around an inch because the inlet is right at the product chambers. You don't have that manifold pipe work. And then once again, just keeping your suction lines as short as possible is the best thing for moving a thick product. I had a customer once that was pumping, I can't even remember what the product was, but it looked like a really thick wallpaper paste or like a drywall mud. They were pumping it from a mixer just onto trays. And so they wanted an AODD for the suction capability because they knew this product doesn't flow and they needed it to be able to pull it out of the mixer. And so they got the pump, but they weren't happy with the discharge flow that they were getting. And so they showed me a video of their setup, and there's like 6 or 8 feet of suction hose just kind of like snaking across the floor to the pump. And on top of that, the pump was on a cart. So I just told them, get a really short hose, wheel that cart over to the mixer. And then once they did that, they got the flow rates they need and their problems were solved. So talking about pump carts and the mobility and the ease of install of these pumps, that brings us to another application where we had a packaging producer that needed to pump solvents, so some flammable materials at one of their plants. So they needed an ATEX pump. They needed it to be easy to maintain because this was a critical application. And so they selected an AODD because the air, having it being air powered means it's kind of intrinsically safe. There's no risk of electrical ignition. They're easy to maintain. And then they were maintaining the pumps in place, but often in these hazardous environments, you're going to take the pump out before you do the maintenance. And so having a pump that's easy to mount to a cart or easy to move is a great benefit of an AODD pump. And so for this producer, they ended up buying 6 of our diaphragm pumps and mounting them up like on a table, so at about waist height, so they could quickly and easily get in there and service the pumps in case anything were to fail. And then on top of, so you've got ATEX rated pumps is kind of a rating in the UK and the EU for explosive environments. But another kind of hazardous environment would be with chemicals or acids. And so that's another place that the AODD pump shines. With a shaft seal on a pump that has a rotating component, we talked about how the product is the lubricant and the coolant for that seal. And how it does that is it's currently leaking. Essentially, it's a controlled leak. You're having a little bit of product seep past, and it'll evaporate or leak out and take some of the heat from that seal with it. But if you're pumping, aggressive acids or caustic chemicals, you don't want that product leaking out at all. And the AODD is a sealless design, so it's great for that. And then on top of that, we have added features like backup diaphragms, so you could have 2 sets of diaphragms. So in your primary set that's doing all the work, if that were to fail, your product is caught in a secondary set of diaphragms. And then with that, you can pair different ways of notifying the user that, hey, the diaphragms failed, or you can have it automatically shut off the pump. So there's a lot of features that make these great for those more dangerous applications. We've had a skid manufacturer who's purchased a number of these pumps for a pharmaceutical company who's using it to pump their solvent waste. And so they've got these pretty aggressive chemicals they're pumping, but they want to make sure they don't get out if there's a leak, if anything is to go wrong. And they even had it in a really tight spot too. And so we were able to get them over a dozen of pumps that can handle these corrosive products. So it was a Hastelloy pump, exotic material that was resistant to it. We had the 2 sets, so the backup diaphragms to prevent any leak. It had auto shut off on it, and it was small enough to fit into the space that they had. And so that was a big reason why they went with the AODD instead of a different style of pump. And so we spent a long time talking about the benefits and why you would pick an AODD pump. But now we're going to talk about some really good reasons why you shouldn't pick them. Because of how they work, it's that diaphragm's moving back and forth. There is a very pulsed flow. It's moving one chunk of fluid, and then it's moving another chunk of fluid. And with your viscous products, it's very evident. So if you have an application where you want precise metering, this is probably not the pump for it, because you're going to have these peaks and valleys in your flow. And if you're trying to get a really precise amount of product every time, depending on where you are, you could be pretty far off. Some of your conventional style AODDs with the pipework manifolds can be time consuming to maintain. You've got, especially on like the bolted styles, you can have, 20, 30 bolts that you have to take apart just to get to the diaphragms. And that just takes a lot of time, and then you've got a lot of components, so there's just a lot more room for error when putting things back together. AODDs typically have a low positive suction pressure limit. So in general, you shouldn't put more than 10 pounds of positive pressure to the inlet of an AODD. And so like on a traditional one, it's to prevent it from pushing the diaphragms back over the thrust tube and stressing them that way. And on the conventional ones, it actually kind of balloons them out, a similar issue. So you don't want too much positive inlet pressure. And so that can create an issue with CIP, because generally you're trying to force as much of that cleaning product in to achieve the velocities you need. There are some innovations that help us get around that and still CIP these pumps. Another issue is you do have to have air, and the air needs to be clean and dry. And so if you don't have a filter dryer on your compressed air line, the silencers and the spool valves they'll just foul up a lot quicker, and you'll just get a lot more performance issues from your pump. So you have to have air, and you have to make sure your air is clean and dry. And then while we're talking about air compressors, powering a pump with an air compressor, there's a little bit of an efficiency loss because you're going from that electric to an air compressor, and that pressurized air is going through a line to your pump. Whereas with a low pump, for example, it's electric motor, gear reducer, or sometimes even just electric motor directly bolted to that pump. So you have a little bit higher efficiency on those. So a little bit of a decision guide, kind of a checklist. All the pumps listed on the right are pumps that are good at those applications, and the bolded ones would be the ones that are kind of like the best. So shear sensitive products, your AODD is excellent, but low gear and twin screw can also perform those, generally at lower RPMs. For suction lifting, AODD is going to be the best option, same as with running dry or deadheading the pump. For viscosity, lobe and twin screws can do better with high viscosity because they have higher pressure ratings. And typically the thicker a product, the higher your pressures are going to be. So as long as just a short transfer of a thick product, going from a drum into a mixer or something like that, the AODD is a good option. But if you're going from, a loading dock a couple hundred feet across the facility, you're going to want a lobe or a twin screw if you're doing a thick product that distance. If there's solids, a low pump is great, or an AODD is great. And where I said the majority of your diaphragm pumps have check balls, there are some that have flap checks, and those can handle even larger solids than your typical AODDs. Lobes and twin screws can handle some solids too, but you have to run them much slower, and you're kind of speccing them for the solids, whereas an AODD just kind of handles them pretty easily without any special requirements or considerations. For hazardous or explosive areas, the AODDs are also kind of one of the best options. You can use electric pumps in those locations, but then you have to make sure that your motors and any other electric components meet the standards of that location. So in Europe, you have to make sure it's an ATEX motor, or in the US, there's a class and div motors that you have to make sure you've got the right class, the right div for that location. So the AOD is just kind of intrinsically safe for those areas. The other pumps, you have to take a lot of considerations to make sure they're safe for those areas. And then the last one is if you need a pulsation-free, extremely smooth flow, the twin screw is going to be the smoothest, and then lobe and gear pumps, depending on how they're spec'd, can have some pretty good pulsation-free, smooth flow. So on to some of the features or little-known things about diaphragm pumps. So we talked about how they can be difficult to clean. So on the traditional ones, you've got those manifolds with all the bolts. There's lots of pieces. It can take around 2 hours to strip and maintain, or strip and clean a pump. And then on top of that, depending on your process, there can be a lot of product left in those suction and delivery manifolds. So if you have like a thick product and you have to stop and then take the pump out of the system to maintain it, those are just all going to be full of product, and it'll take a little bit longer to clean it out. So messy and time consuming to maintain. And so that's where the innovations have come in. So Flowtronic decided that they were going to make a pump specifically for the sanitary, and kind of try and improve upon the double diaphragm design. And so they had two big ideas. What if you put the product in the middle of the pump instead of the outside? So you eliminate that pipework on your manifolds. And then it puts the air side of the diaphragms on the outside, so you can get to them and service them without getting to the wetted portion of the pump. And then what that allowed was, the second idea is, what if you just clamp the whole entire assembly together with one nut? So now instead of having, 30 bolts holding a pump together, there's one nut. You take it off and you have complete access to the diaphragms in the product chamber. And so that is how the Flowtronic one nut was born. So as far as advantages, the time it takes to tear it apart, rebuild it, or clean it and put it back together, it can be done in 15 minutes. So huge time savings on the clean out of place and the maintenance. You can inspect the backside of the diaphragms with the pump still in line. So you're having some issue, it's performing weird, you can just take off that nut, take off the air domes, and you're looking at the internals of the pump with it still piped into your process. And you haven't touched any of the wetted components yet. The air valve is mounted externally on those air domes, so you have it's readily accessible and easy to service and inspect while the pump's running and while the pump's in place, and just significantly less components. And with less components, you have less complexity, and it's just easier to make sure things go right. Some other benefits, it's a smaller footprint. So for the same size pump, it takes up less space, great for confined areas and small facilities. We're also able to put a reinforcing backing plate on the diaphragms. This allows for increased diaphragm life, but mainly it allows for CIP, which lets us get high pressures on the suction side. So with those reinforced diaphragms, we can take the full pressure rating of the pump, so 7.2 bar, 100 psi, as positive inlet suction pressure. And the main benefit of that is true CIP of an AODD. A lot of people think you can't truly CIP an AODD, and that's because with conventional pumps, you can't exceed that 10 psi on the inlet. And then often to achieve the velocities for COP, you're going to need more than 10 psi. And so the workaround typically involves some complex bypass systems and valves, and so you're routing some product around the AODD to make sure you've got the correct velocity through your whole system, but you're not damaging your pump. But with the Unibloc or the Flowtronic AODD, you have those reinforced diaphragms on there, and you can just use the pump and route all your CIP product through the pump without damaging it. And so this kind of just shows, you can see there's a little backing plate on the right side in between the diaphragm and the air dome. That's what allows us to CIP this pump. We also have options where we can have self-draining seats, high temp diaphragms to make sure you can handle the temperature needed for CIP. And just, it gets you a really easy to clean pump, whether you're taking it apart or cleaning it in place. And you don't have to run the pump with the backing plates on there during CIP, but you don't have to run the pump to make sure you've got air supporting the back sides. The only reason you're running it is to make sure it's cleaning all parts of that thrust tube. We talked about the elimination of the manifold pipe work. This can become a really important thing to think about depending on your application. So we had a cosmetics manufacturer that was doing a lot of mixing of different cosmetics and servicing a lot of different lines of cosmetics. And so they needed something that would handle different viscosities. Some of the products needed to be CIP'd while others needed to be COP'd. And so they had a lot of turnover with these products. And on top of that, some of the products were incredibly expensive, so up to $170 an ounce. And so if you had the conventional style with those manifolds, you can end up with a lot of product left inside that pump. And so if you've got, a couple pounds of product left in that pump, it could be thousands of dollars that they were losing every single time they switched to a new product. And so we were able to supply them with our alternative, the one nut style. They were able to CIP it and COP it, and they had 60% less product waste. So they had immense savings on the maintenance of the pump, savings on the product loss, and just a much easier time with this application with the one nut AODD. And then just some kind of general things to consider when looking at an AODD pump. What you would need to know is what is the product, and not just what it is, but its viscosity and the viscosity at the exact temperature that your process is going to happen at. Lately, for some reason, I've had a lot of beef tallow applications that I've been working on, and depending on if it's 30 degrees refrigerated or 110 degrees, that beef tallow is going to be incredibly different viscosity. So either solid or a really thin oil. And so viscosity of your product is important, but also the temperature of your process. The flow rate, obviously, we need to know to size a pump, and then whatever your discharge and suction conditions are. And that's important for estimating and calculating the pressure that you're going to have on the suction side and the discharge side as well. Some more in-depth stuff. The more complicated or the more specific your application is, the more information we'll need. Kind of example for this is we're working with an explosive manufacturer on a pump. And so if you're pumping an oil, a canola oil, temperature, flow, pressure, that's fine. If you're pumping explosives, we want to know every single thing about the pump, how it behaves at a specific temperature, what is our max temperature, what's our kind of margin of error. We want to know every single thing possible because it's a very critical application. So just knowing kind of what your application is, and then as much details as will be needed to make sure we accurately can size the pump for you. So if there's solids, we'll need to know what those are. And then cleaning considerations are always important. How are you going to clean the pump? Because that can make a big difference on how we spec it. Some case studies. We had a kimchi sauce manufacturer. They were using a lobe pump, and they were having issues with the lobes galling. So the lobes were hitting the housing and they were getting metal in their product. And every time that happens, they had to shut down their line. They had to throw product out. They had to figure out what was wrong with the pump. So they were losing hours of time as well as product. And so they were looking to us for a solution. And so we gave them a diaphragm pump. And so the only moving component is those diaphragms and the check balls. There's never any chance of a metal on metal or any sort of where you're chipping anything off in there. So we eliminated that. And then with the CIP capability of the pump, it really made cleaning easy, and they were able to keep their CIP system that they had with the rotary lobe pump. Some other considerations is just the benefits of the pump can kind of stack and compound. So for that cosmetics one, they ended up buying, it was around 20 pumps. And so when you think of every time they were switching a product, with a conventional AODD, that was 2 hours to clean it. So they went from 2 hours to 15 minutes, or they were able to CIP it. And so you kind of, the time saving there is huge. And then it just kind of all builds. So the pump may cost a little bit more than a conventional one if you're getting all the features. So you pay a little bit more for bells and whistles, but you need to take into account the whole picture on how much you're saving and how much the process is being improved, because it will pay for itself pretty quickly. And so we at Unibloc have a lot to offer. We've got a lot of resources on our website. If you have any questions or anything to look back, we have a lot of resources on our website if you have any questions or anything that you're looking for. And then we have a wide variety of products that we can offer. Thank you all for joining and listening. And if you have any questions, please let us know.
Caleb, thank you for that great presentation. In just a moment, we'll begin the Q&A session, but attendees, if you would like a certificate of participation for today's webinar, you can do so by clicking the View Certificate button, and it'll download it from there. And if you have questions you haven't sent over yet, now's the time to do so. Keep those questions coming, and we'll keep pulling them from the chat and get to as many as possible. So at this time, it is our pleasure to begin the Q&A. The first question we've got is, does a pulsation dampener work well with an AODD pump?
Yeah, the pulsation dampeners do work well with them, and I know we offer them as an option to come with the pump. And then there's just going to be some considerations with application, what the product is, how far you're pumping it, and that'll kind of change how smooth your flow will get. But it is definitely a way to mitigate the pulsation in their flow.
Okay, sounds good. For maximum air pressure or for maximum pressure development by the pump, is it purely limited by the air pressure alone, or do you need to take into account suction pressure component as well?
Okay, so with an AODD pump, they normally work on a one-to-one basis. Whatever the air pressure you give the pump, that's the maximum that it can ever achieve of liquid pressure. So you don't have to take into account the suction positive pressure, unless in some weird system it was higher than your air pressure, in which case obviously it would go straight through the pump and that would be the main pressure. But if you're looking at the pressure the pump can produce on its own, it's purely equal to the air pressure you give it.
Okay, sounds good.
And that was Leighton. I don't know if we introduced him, but he's a coworker who's been here at Flowtronic for 30 years and is an expert on these pumps.
Yes, thank you, Leighton. We've got several questions coming in about this, so I'm going to go ahead and address it. We'll get an email out to you later today with a link to the recording of this presentation. So if you want to rewatch any of that, you'll get that in your inbox in just a few hours. So, and it'll also be available on pumpsandsystems.com. The next question is, are AODD pumps suitable for allergen sensitive or multi-product lines?
Right. Okay. So yes, they are, because you can, as long as you pick a model that can be obviously cleaned thoroughly between different products. Obviously, the lines themselves will be engineered to deal with allergens and things like this. But if the pumps can be cleaned, or even all the internals can be changed if you're worried. So yes, AODD pumps can be used where there's allergens involved.
Sounds good. The next question is, does flow variability increase with a decrease in demanded flow?
So the variability is somewhat fixed, because diaphragm pumps are a positive displacement pump. So it's going to move the same amount of product per stroke or per cycle. And so if you're running at a lower flow rate, the pulses would be longer, but they would be the same amount of product. Because it's always going to move, like if you move a liter per cycle, whether you're doing 10 cycles a minute or 20 cycles a minute, each one of those cycles is going to do 1 liter. So it kind of changes how close together the peaks and valleys are, but the peaks and valleys would be the same.
Okay, sounds good. The next question is, are the housings typically cast iron or stainless?
Okay, so yeah, sorry. I mean, you can get AODD pumps basically with wetting materials of either. They can be cast iron, they can be stainless, it can be polypropylene, they can be any material you want to mention that you can machine. So it's all about the chemical compatibility of what you're trying to pump.
Sounds good. The next question is, how easy is it to strip, inspect, and reassemble an AODD pump in hygienic service?
Again, as was pointed out in the slides, it all depends on the model manufacturer of the pump that you've picked. There are pumps that are specifically better than others and easier to strip and inspect. All AODD pumps can obviously be stripped, but there are certain versions that make it a lot easier and a lot quicker. So it's something that you need to look at when you're speccing your AODD pump.
Sounds good. The next question is, Can AODD pumps handle solids without damaging them?
Again, it was covered in the slides in a way. There are AODD pumps that will handle solids up to chicken fillets, boiled eggs. So depending on what you want to handle, again, different configurations of AODD pump can handle different sizes of solids. It's the information that you need to give people before you ask them to spec a pump basically people need to know the size of the solids and very often the percentage of damage that you can allow. So, and then different types of AODD pumps can treat them more gentle. I mean, a quick tip is to make the pump bigger than you need for the flow, so that the internals are more space to let the products go through.
Sounds good. The next question is, can AODD pumps be fully CIP and SIP compatible?
You have to be very careful with this one because the vast majority of AODD pumps can be, right. So clean in place is a term. You can use any pump to pump the material, the CIP liquids itself. Okay, if you want to use a CIP rig that pushes the liquids through the pump and through the pipework, then you have to pick a pump that can take up to the 104 psi 7 bar. So you're limited in your choices there. So you need to ask the manufacturer whether the pumps can take the CIP pressure through the main body or not. With the SIP, you have to be very careful again because that's steam in place. So your temperatures go high and your pressures go high to get the temperatures. Again, you need to check with the manufacturer you're dealing with whether the pumps can be SIP.
Sounds good. The next question is, what diaphragm or O-ring seals do you recommend for liquid ammonia?
So for this one.
Okay, so with liquid ammonia, sorry, go on, Colin.
PTFE is good, and that's what we standardize on for our diaphragms. We've got different options for diaphragms, and different manufacturers will have even other options potentially. So PTFE is a pretty common one across the industry that would be good with liquid ammonia. But then the main thing is knowing the chemical compatibility of your product. And generally we can find something that will work with it. But PTFE would be a good material for that.
Sounds good. The next question is, other than the maximum achievable pressure from the pump, how does air pressure PSI affect the operation of the AODD? Does higher air pressure relate to greater compressed air consumption?
So generally you're going to want to run the pump at the lowest air pressure to hit the flow rate that you need. Because as you mentioned, that air consumption, you don't need to supply it with more air than it needs, because then you are just going to have greater losses. So yeah, more is not always better. You just need enough air pressure to do the job.
Sounds good. I know you touched on this some in the presentation, but can you share real-world examples where switching to an AODD pump improved operations?
There's lots and lots of those instances. I mean, one that comes straight to mind is a cosmetics manufacturer that was using a drum and loader with a piston pump fitted to it. And their problem was the piston pump was so hard to clean. It couldn't be CIP'd. You had to strip and clean it. So they went for a drum and loading system with an AODD pump connected to it. And then they were able to COP and CIP. So they saved a lot of time between batches. And that was a manufacturer that makes a lot of different things. So they could be using four different products a day. So they saved a lot of money changing to AODDs on that. I've also seen people in the chocolate industry who are using gear pumps for basically recirculating the chocolate through some of their mills. And they also find that the AODD saves them time on the cleaning. It's a lot easier to jacket an AODD pump, so they keep the temperature of their chocolates correct. So that's a few examples, but there's a lot of examples. It's easier if somebody's got problems to give us the pain points, and then we can see if an AODD pump is the way to cure those problems, or if one of the other pump ranges we offer is the way to cure their pain.
Sounds good. The next question is, what instrumentation is recommended for AODDs?
So for instrumentation, it's always good to have, like just any extra equipment for the pump. Is pressure gauge. You need to know how much air you're supplying to the pump. And then we talked briefly about having clean, dry air. So you're going to want a filter regulator for the pump so you can control the pressure and the volume of the air going to it. But they are fairly straightforward. So you just have to connect that air to the air valve, and then they're good to go. So not much instrumentation is needed.
Sounds good. The next question is, how do AODD pumps meet sanitary standards like 3A sanitary standards and FDA requirements?
Okay, so FDA requirements, the FDA do not approve pump design. They only approve the materials that you make the pump out of. So as long as your materials are FDA approved on the wetted sides, then your pump is basically an FDA compliant pump. Some manufacturers, the whole pump, wetted and non-wetted, manufactured from FDA compliant materials. In hygiene and sanitary land, and especially pharmaceutical land, that's very important because they like to have the whole pump made from FDA. With regards to 3A sanitary, basically what you do is you have to come up with a design of pumps that includes the sanitary sort of levels with, I mean, for example, surface finish, it has to be 32 RA internally. You have to have a leak detection system, minimum internal radiuses, and the O-ring design has to be a sanitary design. You send that to 3A, and then 3A either approve or not. So if somebody's got a 3A badge, that means the 3A sanitary people have approved the design of the pump.
Sounds good. Well, if anybody else has any questions, again, feel free to send those through the Q&A box. Even if we don't get to them on the webinar, we'll get those to the presenters and they'll answer those offline. Like I said, a reminder that today's presentation will be sent in an email from us later today. You'll be able to access playback and presentation from this event. But also please feel free to visit pumpsandsystems.com for more on this topic and additional educational webinars, including those from Unibloc. All right, we've got a few more coming in.
So for the O-ring material,
yeah,
there's just kind of general options. Sorry, I saw the question for different O-ring materials,
You're good.
but so like for us, standard wetted O-rings are PTFE, but there's options for Viton or EPDM, or it's just making sure that we have the right material to match whatever product is being pumped.
Yeah, I mean, this was the one with the ammonia, was it?
Yes.
I think it was. So, I mean, basically, experience, I would say you'd go for the 316 pump body, and then PDFE diaphragms, PDFE balls and seats, sorry, stainless steel seats, and then PDFE O-rings. If the customer wanted to use a different O-ring, you could go with EPDM, or you could go encapsulated. So we have experience of pumping the ammonia material. There isn't a material that you can't pump, because we can basically get O-rings in just about everything, all the way up to Cal Res, which is pretty multiple use.
Sounds good. The next question is, how do you recommend AODDs be grounded/earthed? Can this be done via connected metal pipework or designated discharge points?
We actually have a specific spec. So these were designed in the UK, so they follow the ATEX certifications. And so we actually have grounding straps that we supply with the pump if we know it's going to be an explosive environment. And so they can be grounded with those grounding straps to make sure that the entire pump is grounded, and then from the foot plate to some ground in the facility.
Sounds good. The next question is, how easy is an AODD pump to operate?
In its very easiest form, it's provided with some liquid, some pipes to get the liquid into it and out of it, supply air, turn the air on, and the pump will operate. It's all application specific. I mean, we've got applications that are a lot more complicated than that, where they run by systems to achieve certain things. But to actually operate an AODD pump, you turn the air on, the pump cycles, and if there's liquid anywhere near it, it'll pull the liquids, put the liquids the other side.
Yep.
Sounds good. Okay, everybody, that does it for time today, which brings our webinar to a close. Again, if you have any additional questions, go ahead and throw those in that Q&A box. We'll get them to the presenter so they can answer them offline. And then we'd like to thank Caleb and Leighton and the Unibloc Hygienic Technologies team for today's presentation. And thank you to everyone for taking the time to join us today. I hope you all have a great day.